Hello children, we are going to start with practice set 5.1. Question 1. Find the distance between each of the following pairs of points. Point A and B are given, whose coordinates are given. Point A coordinates are 2, 3 and B 4, 1. So let A equals to x1, y1 and B equals to x2, y2 be the given points. Therefore, x1 equals to 2, y1 equals to 3, x2 equals to 4, y2 equals to 1. By distance formula, we have seen the distance formula. Distance AB, where the 2-point coordinates are given. Therefore, distance AB equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the values of x2, x1, y2, y1 and calculating here 4 minus 2 whole square plus 1 minus 3 whole square equals to 2 square minus 2 square. 2 square is 4 and minus square is also positive. That is minus 2 square is plus 4. 4 plus 4, 8 equals to root 8. Therefore, distance AB equals to 2 root 2 units. Therefore, the distance between the points A and B is 2 root 2 units. Very simple problem it is. Next points, P and Q are given. P coordinates are minus 5, 7. Q coordinates are minus 1, 3. Let P x1, y1 and Q x2, y2 be the given points. Therefore, x1 equals to minus 5, y1 equals to 7, x2 equals to minus 1, y2 equals to 3. By distance formula, distance PQ equals to, distance formula remains the same, root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the value, you can see here minus 1 minus 5 whole square. See the calculations here, very important. Plus 3 minus 7 whole square. So minus 1 minus 5 is plus 5. So minus 1 plus 5 whole square plus 3 minus 7 whole square. Here it will be 4 square plus minus 4 square, 16 plus 16. That is root 16 plus 16 is root 32. Therefore, distance PQ equals to 4 root 2. 16 2s are 32. Square root of 16, 4 will come out. So 4 root 2 units. The distance between the points P and Q is 4 root 2 units. Third problem. Coordinates of R are 0 and minus 3. S is 0 and 5, 2. That is 52. Let R x1, y1 and S x2, y2 be the given points. Therefore, x1 equals to 0, y1 equals to minus 3, x2 equals to 0, y2 equals to 52. Therefore, by distance formula, distance RS equals to root of x2 minus x1 whole square plus y2 minus y1 whole square. Now here you see x coordinate for both the points are 0 only. So 0 minus 0 whole square plus in another bracket 5 by 2 minus 3 whole square. So here 0 minus 0 it will be 0 only. So only y coordinate will be here. 5 by 2 minus will become plus 3 whole square. Taking LCM here, 5 plus 6 upon 2. That is 11 by 2 whole square. Root of 11 by 2 whole square. Square root of any square number is the number itself. Therefore, here 11 by 2 square, its square root is taken. So, number itself, that is 11 by 2. So, distance RS is 11 by 2 units. We can write 5.5 units also. Therefore, distance RS equals to 11 by 2 units. The distance between the points R and S is 11 by 2 units. Next problem, L. Coordinates are 5 minus 8, M minus 7 minus 3. So let L x1 y1 and m x2 y2 be the given points. Therefore, x1 equals to 5, y1 equals to minus 8, x2 equals to minus 7, y2 equals to minus 3. Therefore, by distance formula, distance Lm equals to root of x2 minus x1 whole square plus y2 minus y1 whole square equals to, substituting the values of x2, x1, y2, y1 in this equation and simplifying it, will get root of 169. Therefore, distance Lm equals to 13 units. Therefore, the distance between the points L and M is 13 units. Next, coordinates of point T are minus 3, 6, R is 9, minus 10. Again, taking as T coordinate x1, y1, R coordinate as x2, y2. Substituting the values of these terms in the distance formula for distance TR, here we will calculate, simplify it, and we will get root of 400. Root of 400 you know very well, it comes to 20. Therefore, the distance between the points T and R is 20 units. Next problem, W coordinates are minus 7 by 2, 4, and X coordinate is 11, 4. Let W x1 y1 and x2 y2 be the given points. Therefore, x1 equals to, please take note here it is minus 7 by 2. y1 equals to 4, x2 equals to 11, y2 equals to 4. Therefore, distance wx equals to, substituting the values here, 11 minus 7 by 2 whole square plus 4 minus 4 square. Here y coordinates are getting 0. So only x coordinate, 11 plus 7 by 2 whole square. So simplifying it, you will get 22 plus 7 upon 2, that is 29 by 2 whole square, and its square root equals to number itself, that is 29 by 2 units. Therefore, the distance between the points W and X is 29 by 2 units. Next problem, determine whether the points are collinear. Points are given here. A coordinate 1 minus 3, B coordinate 2 minus 5, C coordinate minus 4, 7. By distance formula, distance AB equals to, substitute the value of the coordinates here of A and B, we get distance AB equals to root 5. Distance, to find out distance BC, again apply the distance formula here, substitute the coordinates of the point B and C, we will get, after calculations, distance BC equals to root 180. Root 180 is nothing but root of 36 into 5. Root of 36 is 6. So distance BC will be 6 root 5. To calculate distance AC, by the distance formula, substitute the coordinates of point A and C, and you will get the simplification root of 125. Therefore, distance AC equals to 5 root 5. Now you have to add the two segments. On adding 1 and 3, therefore distance AB plus AC. These are the two small segments. If it equals to the third segment, then we say that they are collinear. So therefore, distance AB plus distance AC equals to root 5 plus 5 root 5 equals to 6 root 5. But 6 root 5 is nothing but the value of distance BC from 2. Therefore, points ABC are collinear. Next, related to points L and M, L, M, N, their coordinates are given. We have to find out the distance LM. Now we know how to find out the distance between the two coordinates. Calculate distance between LM. You will get root of 45 equals to 9 5s are 45. So root of 9 is 3. So it will be 3 root 5. Distance MN. Calculate the distance MN by the coordinates given for M and N. You will get distance mn equals to root of 65. Now your factors are not further such that we can take any term outside the root. So root 65 only will keep here. And distance ln equals to, again the coordinates of point L and N. We have to substitute the value and calculate the distance ln. It comes to root 50. 50 means 25 into 2. It will equals to 5 root 2. On adding 1 and 3, we get distance lm plus distance ln equals to 3 root 5 plus 5 root 2. Here it will not be equal to, it is not equal to root of 65. Therefore, distance lm plus distance ln is not equals to distance mn from 2. Therefore, the points L and N are not collinear. If they are equal, they are collinear. If it is not equal, then they are not collinear. Next problem based on this. Point R, D and S are given. Again by distance formula, we will calculate distance RD. We get distance RD equals to root 8. Distance DS, we get root 5. Distance RS, again we get root 25 equals to 5. On adding 1 and 2, we are getting distance RD plus distance DS equals to root of 8 plus root of 5 is not equal to 5. Therefore, distance RD plus distance DS are not equal to distance RS from 3. Therefore, the points R, D and S are not collinear. Another example, coordinates of point P, Q, R are given. By distance formula, again we have to calculate the distance PQ. By substituting the values of coordinates of point P and Q, you can calculate distance PQ equals to root 10. Distance QR equals to, substituting the coordinates of point Q and R, you will get distance QR equals to root 10. To calculate distance PR by distance formula, substitute the coordinates of point P and R, you will get distance PR equals to 2 root 10. On adding 1 and 2, distance PQ plus distance QR equals to root 10 plus root 10 equals to 2 root 10. Therefore, distance PQ and distance QR equals to distance PR from 3. Therefore, points P, Q and R are collinear. Next question. Find the point on the x-axis which is equidistant from A minus 3, 4 and B 1 minus 4. Let point C be on the x-axis which is equidistance from point A and B. Point C lies on x-axis as per the given condition. Therefore, its y coordinate is 0. You know all the points on x-axis, y coordinate is 0. So let's see x 0. C is equidistant from point AB, A and B. Therefore, AC equals to AB. So applying this condition, root of distance formula we have to apply for AC and distance formula for BC, and both are equal. By distance formula it is given here. So x minus minus 3 whole bracket square plus 0 minus 4 whole square equals to x minus 1 whole square plus 0 minus minus 4 whole bracket square. Simplifying this, you will get x minus minus 3 will be x plus 3. Here it is, sorry, in this step only we are doing squaring both the sides. Squaring both the sides. So square root on both the sides will be cancelled. So here After that, simplifying this, x plus 3 whole square plus minus 4 whole square equals to x minus 1 whole square plus 4 square. Simplify this. Expansion of a plus b whole square is x square plus 6x plus 9 plus 16 equals to x square minus 2x plus 1 plus 16. 16 will get cancelled. X square will get cancelled. What is left? 6x minus 2x. Bring on this side, it will be 8x. Here is plus 1. Plus 9 will go on the other side. Here it is plus 1. It will become minus 8. Therefore, x equals to minus 8 divided by 8 equals to minus 1. Therefore, the point on x-axis, which is equidistant from point A and B, is minus 1, 0. Next problem. Verify that points P, Q, and R are vertices of a right angle triangle. Now, distance between the 2 points we have to take. What we will do, whenever the such points are given for triangle, for quadrilateral, we will find out the distance between all the points, such as by distance formula here, distance PQ equals to, now I'm sure students you know how to find out the distance between the 2 points when the coordinates are given. So directly I'm explaining the point here. So distance PQ you calculate, it will come to 4. Distance QR equals to 5. Distance PR equals to root 41. Therefore, now here it is taken PR square equals to root 41 whole square equals to 41. Distance PQ square equals to, PQ was 4, so 4 square. Distance QR square, 5 square equals to 16 plus 25 equals to 41. Therefore, from one end to substituting the values of PQ plus QR and a square. So here PR square equals to PQ square plus QR square from 3. Therefore, triangle PQR is a right angle triangle. The reason for this, converse of Pythagoras theorem. Therefore, points P, Q and R are the vertices of a right angle triangle. When 3 coordinates. Next question. Show that points P, Q, R and S are the vertices of a parallelogram. Method remains the same. Find the distance of between all the points. So PQ equals to root of 50, QR root 32, RS root 50, PS root 32. Now here you see PQ equals to RS from 1 and 3, QR equals to PS from 2 and 4. A quadrilateral is a parallelogram if both the pairs of its opposite sides are congruent. As opposite sides here are shown equal, congruent, therefore we say that quadrilateral PQRS is a parallelogram. Therefore, points PQ, R and S are the vertices of a parallelogram. Next question. Show that the points A, B, C, D are vertices of rhombus ABCD. Again, by distance formula, find out the distance between all the 4 segments. AB equals to root 90, BC equals to root 90, CD equals to root 90, and AD also equals to root 90. From equation 1 to 4, AB equals to BC equals to CD equals to AD. These are nothing but the sides of the quadrilateral and all are equal. In a quadrilateral, if all the sides are equal, then it is a rhombus. Therefore, quadrilateral ABCD is a rhombus. Therefore, points A, B, C and D are the vertices of rhombus ABCD. Next problem. Here we have to find out the x, unknown coordinate, x coordinate for point L. Find x if the distance between points L, coordinates are x and 7 and m 1 and 15 is 10. The distance between the 2 points is given. So here distance Lm is given. Again by the distance formula only, distance Lm equals to root of x2 minus x1 whole square plus y2 minus y1 whole square, where these are the x2, x1, y2, y1 are the coordinates of point L and M. So 1 minus x whole square plus 15 minus 7 whole square, 1 minus x square plus 8 square equals to 10, because the distance Lm is given already equals to 10. Substitute here. Now simplify. For simplifying, here it is 10 equals to root of 1 minus x whole square plus 8 square by squaring both the sides. So here if I take the square, square and square root will get cancelled. So what is left? 1 minus x square plus 64, and here 10 square will become 100. Therefore 1 minus x square equals to 100 minus 64. 64 went on the other side of the equal sign. So 1 minus x square equals to 36. Here directly the square root on both the sides is taken. Therefore 1 minus x square, its square root will be 1 minus x equals to root of 36. But when we take square root on both the sides, plus minus sign comes. So here it will take plus minus sign here. Taking square root of both the sides, we get 1 minus x equals to plus minus 6. Therefore, 1 minus x equals to minus 6 or 1 minus x equals to plus 6. Simplifying this, you will get x equals to minus 5 or x equals to 7. Therefore, the value of x is minus 5 or 7. Both are applicable. We have seen in quadratic equation that two values where we get. Next problem, show that the points A, B, C are the vertices of equilateral triangle. Here you might have seen that x coordinate of C is taken as 1 plus 2 root 3. Got it clear? No doubt we will simplify this, but method remains the same. We have to find the distance between all the three segments, that is AB, BC and AC by distance formula. Distance formula you know, substitute for coordinate A and B, you will get distance AB equals to 4. For distance BC, when you are substituting the coordinates for B and C, here B x coordinate is 1 plus 2 root 3. Here you have to substitute 1 plus 2 root 3 minus 1 whole square. Clear? So plus 1 minus 1 will get cancelled. It will be 2 root 3 whole square. Here only calculation is important. Plus minus 2 whole square. 2 square 4, root 3 square 3, 4 into 3 becomes 12. So here 2 square is 4, root 3 square is 3, therefore 4 into 3 will be 12. So here it came 12 plus 4 minus 2 square is 4. That is root 16 equals to again 4. AC, if you simplify by this method only, you will get AC equals to 4. From equation 1, 2 and 3, AB equals to BC equals to AC. Therefore, if all sides are equal, then we say the triangle is an equilateral triangle. Therefore, triangle ABC is an equilateral triangle. Therefore, points A, B and C are the vertices of an equilateral triangle. This much is sufficient for this exercise. In next video, we are going to see practice set 5.2. Till then, take care of yourself. Have a nice time. Thank you.